Hello folks, let's try to do the Leetcode 17 today. This is a very interesting problem and very popular problem among the interviewers. It helps you to exercise your C++ skills in this case, since we're going to be doing this in C++, and also you get to practice recursion, and you get to be introduced to terms like breadth first, depth first, and a lot of interesting juices at the end of the day. So without further ado, let's read what the problem is. So it says, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digit to letters is given below. So what used to happen was that um, there was a time when you had these kind of keypads on the telephones where you have this mapping of the number to the to like bunch of letters. So it's kind of one to many mapping if you are more of a mathematically inclined kind of person. So as you can see, it's like 2 is mapped to ABC, 3 is mapped to DEF, and some of the characters are not mapped at all. Oh, sorry, some of the numbers are not mapped at all. So, for example, 0 and 1 are not mapped, and that may be the reason why it's saying containing digits from 2 to 9. In any case, let's look at an example. So 2 and 3. So as you can see, you have to start from the first number like 2. So let's do some little bit of exercise here. So since we know that A is mapped to 2 is mapped to A and B and C, right? And 3 is mapped to D and E and F. So then what happens? You see, you first start with the leftmost digit, which in this case is 2, and fix the mapping for that one. So let's take A. Now you iterate over all the mappings for 3, which is AD, AE, AF. Now you go back to your previous number, which was 2, and advance the index there. So then you start with B, and then you iterate over all the numbers in these, all the letters for the second number. So then you get, what do you get then? Then you get B, D, B, E, BF, right? So that's pretty much the idea. I guess you should be able to figure that out, and you don't need a spoon feeding for that. But let's try to a C++ implementation for that. And so our approach is going to be, as you just saw, it's kind of a recursive, in the sense we call ourselves. So how are you going to do? So as you can see, the function signature is asking for to return a vector of a string. So first thing we're going to do is we will have what is known as a vector of strings, and that would be our local variable, right? We will return that. The idea is we're going to do a return result at one point. Now before that, now what else, how are we going to represent in a data structure for the mapping of the digits to the letters? So for that we can do something like this, and I had this in my cut and paste already, so I don't have to bore you with all these details about how to map these, but basically you get the idea. It's a simple map, and for C++ to compiler to make happy, you have to basically do it outside the class. You can't do it inside the class. So Ideally, apparently, it goes in a header file, but in any case, here let's not focus on C++. Um, Quirks to my, and then here we have, so you go from char to string, right? 2 to ABC, 3 to DF, 4 to GHI. So this map is what basically represents the mapping of digits to corresponding letters. So now what else, so what we can do now? So now first thing we need to do is that, look, if the if you pass me a string of digits like something like, for example, if the input is, let's write this, if the input string is empty, kind of empty, let's say empty, that means like this, we just return is not empty, I would say. So what does empty mean here? So we can write this in bracket in case it's confusing. That's what empty means. Is not empty. Then call a recursive function. Right? So if the input string is not empty, then call a recursive function. So how are we going to do in C++ to say that this string is not empty? So I guess we can say if not digits.empty. This is the C++, I don't know, like Pythonic, something like C++ way of, you could say it's a C++ way of basically deciding if a string is empty or not. So you call the method empty in the string class. So as you can see, and then to say that whether it is not, then you say if not digits empty, and then we are going to, let's call, what we're going to call our recursive function. So let's say compute recursively might be a better idea. Compute recursive. So compute recursive, or find the result. Let's just call it compute recursive. And before we decide on the function signature, let's here what would happen is that, and then basically we can just say return result. How is that? Right? So now compute, now all we need to do is figure out the function signature or the implementation of compute recursive. So compute recursive is recursively going to build these output strings. So void, let's just, I think this is what it's going to be, right? So void compute recursive. Now the first argument we are going to pass is our output string, because what we want is that the function, as you can see, has a void return value. If the function has a void return value, how is it going to return us the result? So that's why we have first argument as the result, then the second argument is going to be an index into the input digits string. So we will call it int I, and the next argument is going to be this string is basically, this argument is, you could say, kind of a tricky one, because this is the one that is basically building your index, your output strings in a way. And then of course we have the digits. Maybe we should have that as the last argument, and then we can have, because I corresponds to the digits, so that we can have first. So I would rather do it this way. How about this? So this is our function signature for the compute recursive, and then let's do the base case first. As you know, every recursive function has a base case, and if you don't know that, you probably want to read that first before you come to do these Leetcode problems of this type. So the base case is what? That when your output string length, like AD in this case, becomes equal to the input string's length, we are basically done with that recursive uh, tree kind of thing. So if you say how we are going to say that, we are going to say the length, and this is in C++. Pretty much, you just have to keep calling these class methods of the string class to basically determine the length and all that. So if that is the case, then what happens? We say then we have one of our results, and we can simply say pushback, and this is another C++ way of putting things at the end of a vector. So basically it's like, hey, we got one of the output strings, and we're going to put it into our result vector, and so that's your base case. Now let's take the recursive case. And what is the recursive case? That is going to be we have to what we need to do first is that for the given character in the input digits, like digits I, we need to find the mapping. So you could say something like this. And how is that? And then now this is slightly C++ way of doing things, is can get a little bit messy, but basically you have to understand that C++ is not your Python, so you have to make sure that the strongly typed, you got to go and read about things like strongly typed, weakly typed languages, and C++ is very particular on the variable declaration and things like that. So this is again, here you have to call a method in the iterator end, and once you have that, within that you have to do a for loop. Why the for loop? Because this for loop is kind of, you could think, is your horizontal movement, or kind of breadth. So the for loop is the one that is kind of breadth going in the horizontally, and recursion is taking care of the vertical side. So how are we going to now? We know that at this point it second, let's just write here, it second represents the value in the dictionary, or HAPS map as they like to call map. So how are we going to do? We say for, again this is very C++ way. So okay, so what should we do now? We have to call compute recursive. That's the recursive part, compute recursive. And then you say result, and then you say I plus 1, and then so here you see why we are saying I plus 1 even though we were passed with I. So that's how you're kind of walking the digits string. So now we say digits here, and then we say char str plus c. This is another interesting thing. So most of the calculation is happening in the during these recursive calls, and So you're going kind of depth as you're doing recursive. You're going kind of in a you're covering the depth. So you're saying A, D, A, E, A, F part, and A, B, and C. That part is coming from the for loop. So and that is happening in a very recursive manner. So at every level that would be happening. So let's see if this gets us what we want. And okay, so are there any problems? We'll find out soon. Okay, compute recursive have a problem. He's saying that expected for have 0. Okay, so that's easy to fix, and that's going to be the real call from the caller, the letter combinations function, which is and then so this is where you're doing the actual call to the recursive function. You start with the index 0 in digits. So in this case, for example, 2 and 3, we are saying how do you start from 2, and that is being taken care by this thing here, 0, and then you have digits. So that's like digits 0. So it's like 2, 3. So that will actually correspond to 2. And then you're calling this current string. You're starting out with current string of null. And as you can see, the current string plus C and these recursive calls will be taking care of that issue. So let's see now. Excuse me. So as you can see, we have a problem, and the problem is that he expected a semicolon. See, so those are all the things you need to keep track when you go to C++ from Python. Okay, so we have a wrong answer. At least it compiles, which is itself is a cause for celebration in C++. But in any case, the reason that could be the case is that think about what bugs we have introduced so far. So maybe the compute recursive is doing its work, but we don't see the value is being reflected in the caller, and that's because we have not passed this as a reference. If you do that, then you would see that whatever the result we come up, like here the result or pushback, these will actually be reflected in the caller. So let's try now again. And there you go, you have your test case passing, and let's try to submit now, and there you go, that passes as well. So everything is looking good. We can probably do some runtime analysis on this function, but before we wind down or before we sign off, let's try to see what were the gotchas in this problem. So the gotchas were, as you can see, understanding that you have to do recursion here, and you have that too in a for loop kind of thing is tricky. And the fact that if you're going to do this in C++, knowing how to walk a, a, a string character by character, so these things should be like second nature to you. You're going to do a lot of C++. That's a very well-known tricks here. I mean, so you should be very comfortable in understanding like what's going on here. All it is like saying for every character in this value, IT second. So remember, at this point, what is this here? IT. This IT actually is a pair. So this iterator result that we get when we do the hash map lookup, we get a pair, and IT first. So maybe I should write here. IT first is the maybe let's write here. IT first is the key, and IT second represents the value. So for example, you might be 2, and then this result would be IT second would be ABC. So that's how it is. So these things should be very clear to you. Idea of using references for modifying the result in the caller also is a very C++. This is a very C++ way of doing that. You might have heard this concept that passing by value, passing by reference, because I was making the mistake that I didn't have this ampersand here, and what was happening is that you see the caller, the value, this result is not being reflected in the caller. So so whenever we return, when the computer cursive returns, it has to basically um, keep this, see this result dot push back. So you want to see the result that we have built up, this output string here, ADA, all this. At the end of the day, when we're done here, when we come to this line 19, it is actually reflected there. And building the map part, I would say, is kind of pretty much what you would have done in Python as well, except the syntax. So you have to be very comfortable with things like map, being how to basically declare this is a Python dictionary kind of thing. Is saying, hey, I need a dictionary where keys will be char and the value will be a string. So this is another very standard, I guess, nothing surprising or very earth-shaking or very too innovative or anything. These things are all well known. So you got to be comfortable with C++ maps or dictionaries, whatever you want to call them. Some people call them associative arrays, like in PHP, but that's up to you. And just having this idea, understanding recursion and the for loop and how to look up the dictionary in C++ is another issue that can basically trip you up. So I would say with that, with those thoughts, I would leave you guys alone and not bother you too much now. I hope you've been liking the channel. If you have any issues, feel free to mention in the comments. I would be more than happy to try another problem, another interesting problem. If you think that's going to help us, and do some practice with coding is always good. It keeps our left side of the brain going after watching a lot of Netflix and a lot of Redditing or not so constructive activities. Let's just say that way. So with good thoughts like these, I will leave you guys for the next video now, and I wish you all the best in your interview and journey. I hope you succeed in some very famous company, maybe one of those FANG companies. And adios. See you next time.